when we're asked to find a solution of an inequality, like this one, we're trying to find all of the ordered pairs that make true statements, right? Let's pretend that we had to draw the line y equals x minus 1. Let's pretend we didn't see that inequality symbol. If we had to plot this, we would do a dot on the y-intercept, right, of -1. And then we'd use the slope up 1 over 1, right, to get to another point. So we go up 1 over 1, up 1, up 1 over 1, up 1 over 1, and we would draw a line. And all of the points on this line would be solutions, like 0, -1 would be a solution. 1, 0 would be a solution. So all the points on the line are solutions. And if you look at that equation and you plug in ordered pairs that you think are on the line and you think are solutions, you can always check, right, to make sure it makes true statements. So if we said, is 1, 0 a solution, we would plug 0 in for y, 1 in for x, and we would ask ourselves, is this true or false? And yes, it's true. So we would say, yes, 1, 0 is a solution. Now, the problem that we're looking at here, y is less than or equal to x minus 1, is very similar. The only difference is we see this inequality symbol. When we see inequalities, it means shading, meaning there's going to be a region on one side of the line where we'll have true statements. We'll have a lot of ordered pairs that make true statements that are solutions. So let's plot our y-intercept of -1, and we're going to use slope of 1 to get to other points. So we'll go up 1, right 1, or we could go down 1, left 1, right? Because that still is positive 1 as the slope. When we see inequality symbols less than or equal to, greater than or equal to, we're going to use closed circles because or equal to means include, so shade inside the circle to include. If we see less than or greater than, we're going to do open circles. If we see or equal to, we're going to do a full line. If we just see less than or greater to, we're going to do a dotted line, meaning we're not going to include that bound. So we're going to do a closed circle on -1, x -1, or I'm sorry, y -1. We close circle here, and we're going to use the slope up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And notice I do closed circles because on this line, which is our bound, we're including these ordered pairs. I can also go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And I can draw my line. Now I know because of this inequality symbol or equal to, I'm going to have a full line that goes through the points, not a dashed. Now it says less than or equal to, so where are the solutions that are less than or equal to x minus 1? Our shading is either going to be on this side of the line or on this side of the line. We have to decide where is that shading. I'm going to test a point that's on one side of the line. So I'm going to test, you can pick any point. I'm going to test one that's far enough away from the line. So I'm going to test 0, 3. Is 0, 3 a solution? So we're going to plug into our inequality. So is 3, then we put that in for the y spot, less than or equal to 0, put 0 in for x, minus 1. So is 3 less than or equal to -1? Is that true or false? It's false, right? So false would mean don't shade that point, don't shade that side, therefore we're shading the other side. And our solutions lie in the shaded region. So all points on the line are solutions and all ordered pairs on this side of the line in the shaded region are also solutions. So there are many solutions. If we look at this next one, we see that the inequality symbol just says greater than. So we're going to do open circles on the bound on that line, and we're going to do a dotted line, meaning we're not including ordered pairs on that line as solutions. So again, my y-intercept is at -1, and I have to do open circles. So that's the spot, up 1 over 1, open circle, up 1 over 1, open circle, up 1 over 1, down 1, left 1, down 1, left 1. And then I'm going to do a clear dashed dotted line, meaning ordered pairs on this bound are not included. And then we need to test to see where the true statements are. So again, I can try 0, 3. It doesn't matter which side you test. So let's test 0, 3. So is 3 greater than 0 minus 1? Is that true or false? Is 3 greater than -1? Yes. True means shade. So true, we're going to shade where that ordered pair was. So we're going to shade this side. So all of the solutions lie in the shaded region. Let's look at the next ones. Describe the graph of the solutions of each inequality. So let's draw the graph. We know we have a y-intercept at 5. Our slope is -3. Now, because of our inequality symbol, it just says less than. So we're going to do open circles on our bound, and we're going to do a dotted line. So let's do open circle on the y-intercept of 5. If our slope is -3, we can do -3 over 1. So we can go down 3, right 1, or we could go up 3, left 1. They both would give us a negative slope line, a line falling down. You're just getting different points on the line in different directions. So we're going to go down 3, right 1, down 1, 2, 3, right 1, open circle. Down 3, 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. I can go back to the y-intercept and go up 3, left 1. 1, 2, 3, left 1, etc. 1, 2, 3, left 1. Now, because it's just less than, it's not or equal to, we have a dashed line, meaning ordered pairs on the line are not included, not solutions. I'm going to test 0, 0. If your line looks far enough away from the origin, that's usually a very easy point to test. So I'm going to test 0, 0. So we're going to go to our inequality and plug 0 in for x and 0 in for y. So is 0 less than -3 times 0 plus 5? Is that true or false? Is 0 less than 5? Yes means shade. So I'm going to do a check mark, and I'm shading this side of the line. So describe the graph. Describe the graph. In this region, the shaded region represents solution. Shaded region equals solutions to the inequality. So if I plug in any ordered pair in this region, they'll make a true statement. Because this is a dotted bound, points on the line are not solutions. Points, ordered pairs in the non-shaded region are not solutions. So points in non-shaded region are not solutions. Okay, let's look at B. First, I'm going to look at the inequality symbol. So greater than or equal to means we're going to have closed circles on the bound, and we're going to have a full line, meaning ordered pairs on that line are included as part of a solution. So we're going to do a dot on the y-axis at 5, that's the y-intercept. Again, the slope is -3, so we can go down 3, right 1. Down 3, right 1. Down 3, right 1. Or up 3, left 1. 1, 2, 3, left 1. We're going to do not the best line. Okay, again, 0, 0. The origin's far enough away, so I'm going to test 0, 0. To see if I should shade that side or the other side. So is 0 greater or equal to -3 times 0 plus 5? Is 0 greater or equal to 5? No. So don't shade. Don't shade the 0, 0 side. So we can put an X. We're not shading that side. We're going to shade the other side. And remember, we're going to say that the non-shaded side shows no solutions. So we have no solutions in that region where I'm pointing. We have solutions in the shaded region. And this time, all of the points on the bound on the line are solutions. Points on the line are solutions. And that's because it's a closed line, so we're including all of the ordered pairs on that line. The remainder of the problems will be in the next video.